Hello, everyone. You are once more welcome to Afrologic's workshop, the second workshop of this month. My name is Kwabu Daniel, a junior software engineer, and I'll be your presenter for this workshop. The workshop is going on under the theme Introduction to Serverless Development with AWS. Now, the person who is going to lead us through this theme will be Mr. Kevin, who is a senior software engineer, and he's going to guide us all through this workshop. So I will leave the floor to Mr. Kevin to guide us and to help us during this workshop understand the main theme and make us to be more brighter and understand it clearly. Thanks, Mr. Kevin. You have the floor.
Thank you very much. And as she's already said, I'm Kevin, and I'll be humbly take you through introduction to serverless development with AWS. So we'll dive right into the subject. So first of all, you can feel free to stop me at any time if you need some clarifications or some more explanation or some points. So from the get-go, we'll talk about serverless computing. What is serverless computing? Serverless computing, in a broad sense, is computation is like the developer trying to execute software without having to worry about infrastructure, because traditionally when you build a software, when you build or you want to program something and host and deploy and host, traditionally you have to think about servers, you have to think about hosting, networking, and how the various servers interact with each other. But with serverless computing, there's someone else that worries about the infrastructure for us. All what we do as developers, we concentrate on our code and we focus on our business logic, and then the infrastructure is being provided by a third party. So in a nutshell, that is what we understand, or that is what we see about serverless computing. So there's usually it's a cloud provider that runs the server and dynamically manages the allocation of machine resources. And pricing is based on the actual amount of resources consumed by an application rather than on pre-purchased units of capacity. So the cloud provider here is the one that provides all the infrastructure, give us the resources in terms of memory, in terms of networking, and all we do is we just get our code ready, and it gives us the environment to be able to deploy and manage our application. And the peculiarity about serverless computing is that we pay for what we consume. That is, we don't pay for the whole infrastructure upfront. What I mean by that is, let's say, for example, you're building a startup or you want to start an application, and you don't at the beginning you have like few users, like let's say you have 2 or 3 users, so you don't need to purchase an infrastructure that has let's say a 64 GB RAM, or that has 3 terabytes of disk space. Maybe from the get-go, your budget is limited and you don't have a lot of users, so you want to start small. So that is an advantage that serverless computing brings us, because with the cloud provider allows us to pay for what we use. So at the beginning, you maybe just need 1 GB of RAM and let's say 50 GB of disk space. So you just pay for that. And as soon as your needs change, or as soon as your application needs increase, you can dynamically allocate more RAM, dynamically allocate more disk space, and then your budget will also dynamically increase according to the extra space or the extra RAM that you ask the provider to make available. So that's what we get with serverless computing. So here we have a little chart, cost benefits of serverless. So one of the biggest advantages of serverless is cost benefits, but even though it's an advantage, but it depends on how on the approach you have. So as you can see from the chart, there with traditional deployment, traditional servers, you have an upfront cost. That is when you pay completely for the infrastructure you need from the get-go. But with serverless, you pay as you use. You pay as you use. That is as you increase the memory, or as you increase the space, or as you increase the resources that you use, that's how your cost increase. But you don't pay for all the complete cost from the get-go. So you have a huge cost benefit when you use serverless computing. Other benefits, scalability. You have scalability, which is another benefit of serverless computing. And here, scalability simply means that you have that your architecture, serverless architecture, is highly scalable because you have the infrastructure that grows dynamically, and you have your code or your application that can grow dynamically with the infrastructure, alongside the infrastructure. So depending on your needs, depending on the growth of your application, you can dynamically scale your application. You can dynamically scale your infrastructure. Like I said, when we were talking about the definition, let's say if you start your application with you just start, you're building a startup, and you have an idea, you're building an application. So from the get-go, you don't have 2,000 users or 3,000 users. Maybe you just have 2 or 3 or 5 users from the start. So you get the resources for that user base. So but the advantage or the benefit of serverless is that you can easily scale your infrastructure depending on how your application is growing. That is, if it happens that suddenly, overnight, let's say overnight, you suddenly have 2,000 users overnight. So the advantage of serverless infrastructures or computing is that your infrastructure can automatically scale to accommodate the extra load on your servers, because the load that your server is going to receive when you have 5 users is not the same as the load that you're going to receive when you have 2,000 users, for example. So infrastructure scales automatically as your application needs increase. So that's an advantage. Simplified backend code. So simplified backend code here means you can simplify your application, because with serverless computing allows you to delocalize some backend processing or some hardcore processing to the cloud, for example, and in such a way that your application is lightweight and does just straightforward or simple API calls to execute certain tasks. For example, let's say you have an application that does heavyweight computing, that does a heavy calculations. Instead of putting that calculation logic in your application, you can remove that logic and implement it in the cloud. And you just have in your application, you just have an API call that calls that logic. The logic does the computation in the cloud and just returns you the results. In that way, your backend code is simplified, because most of the heavyweight is done in the cloud. Yeah, so that's an advantage. Quicker turnaround. Quicker turnaround here is that with serverless, you can quickly or easily get your application running, get the application to the cloud. you can easily get the application to the cloud, or easily get the application to your users, because normally the cloud provides you with certain services that you can quickly leverage, and you don't have to implement them by yourself. For example, there are many clouds today. You have AWS, you have Google Cloud, you have Azure, and with these services, with these cloud providers, they put at the disposal of developers a lot of ready-made services that you can use directly. And this in that way, you just have to application, you just have to write some few lines of code and then make use of those services, and you can quickly deliver a first version of the application to your users. Some services like authentication, authorization, social login through Facebook, Google, and etc. Those are services that are already implemented by most of the cloud providers, so you don't have to implement them again in your code. So your code just have to, for example, you have a form where you get the username and the password from the user, and you just send that. You just call an API and forward that information to the cloud, and then he does the authentication for you, and it returns a token that you can use in your application. So by making use of these cloud providers or the services that they provide, you can easily cut your time to market, and easily deploy your code, or easily move your application to delivery. But so serverless doesn't have only some benefits. There's one major drawback or one major problem with serverless computing the problem is cold start. What is cold start? Cold start is the fact that since your application runs in the cloud, since part of your application runs in the cloud, so the issue is that when your user request your application, for example, when you type on a website that, okay, I want to log in, and then you send a request to the cloud, what the cloud does is that it starts automatically the server so that you can service the request of the user. And as soon as it has finished servicing the user's request, then it shuts down the application, because it shuts down the server, because it cannot leave the server running eternally or running infinitely. So the problem with cold start is that anytime a user requests for an application, if the server has been shut down, the user is going to have some delay before the server responds to the user. So that's what is called as cold start, because anytime the user requests, the cloud provider has to start the server so they can service the request. So sometimes the first user that requests the application, that requests the service, will get a long start, but for subsequent users, the start is going to be a little bit faster. So that is a problem with serverless, is that sometimes first users experience longer response than subsequent users. So now let's dive into serverless with AWS. AWS normally is a cloud provider. Amazon Web Services is a cloud provider that has implemented a lot of services to facilitate or to make it easy for developers to develop applications and to go to market. And some of those services we have services such as Lambda functions, we have S3, we have API gateway, we have Amazon recognition, and lots of other services. So some of these services are already made in such a way that it's easy to incorporate into your architecture, because it works perfectly with the serverless architecture. And we're going to see shortly how these services work together to be able to facilitate or to be able to make it easy for a developer to put in place a serverless application using AWS. Okay. So to begin your journey on AWS, so if you want to start developing on AWS, there are some few things that you need to do, because there's as I said, AWS provides many services that you can leverage in your applications, and they also provide a 12 months free period or trial period that any developer or anybody can use to able to do some proof of concepts, and to try out the various services that they offer. So in order to benefit from these services, or from this 12-month period, what you need to do is to just go on to the AWS website, and then create a free account. And once you create a free account, you're able to access some services such as EC2, Lambda, DynamoDB, SNS, and much more. So you can be able to leverage these services for free during the 12 months period in your own applications. EC2 is a service that enables us to create virtual computers in the cloud. DynamoDB is a database. It's a cloud database. No SQL database that can use to build applications. And SNS is a notification service. So it helps us to build notifications in such a way that when events happen in our application, we can use SNS to notify our users through email or through SMS. So these are some of the services that are available in the free tier, in the free account that you're going to create on AWS. So today we are going to go through an sample application, just a small application, to see how we can leverage the services provided by AWS to be able to build simple but powerful applications. So the application I'm going to show you during our demo, I'm going to show you how I used API Gateway, Lambda, S3, and AWS Recognition to build a small application that can extract features from pictures that you upload. For example, if you want to upload a picture, if somebody you can build an application that uploads a picture, and you can leverage AWS to be able to detect features in that application. How many people are in the application? Are they male or are they females? What are their ages? Are they smiling? Are they frowning? So you can do some image analysis on pictures that your user upload. So we're going to see how this can be done using AWS. So this is a small architectural diagram of the application. So the user makes a request to API Gateway. API Gateway is a service. It's an AWS service that enables you to define an API that your users can call, through which a user can call services implemented in the cloud, as I'm going to show you later. So in the Lambda function here is a function that the developer writes, and this function is like the business logic that you want to implement. That is the like I'm going to show you the image extraction, the image loading, and everything happens in our Lambda function. So the user has to upload the image through an API gateway to our Lambda function, and our Lambda function is now going to call an AWS service call recognition, and send. You're going to send the image to that service, and the service is going to extract all the features that are required and send it back to the Lambda function, and the Lambda function is now going to extract. It's not going to extract the response, build the response, and sends back the response to the user. So this is a basic scenario that shows how you can use the services provided by AWS to build a serverless application. You're not going to host any infrastructure. All the infrastructure is going to be hosted by AWS. All what you do is you just just send a request through API gateway to AWS, and AWS does all the calculations, all the processing for you, and it just sends you back a response. So this is basic serverless application. So now we're going to move to the demo phase.
Thanks, Mr. Kevin, for this genuine presentation and for all the clarifications that you were giving to us about serverless development with AWS. Now, before going to our different demo phases, these are the different informations about the different things that we are going to give, that we are showing, and yeah, then we are giving one is big data, and the solutions that we give is on big data, and also is on DevOps engineering. You can join us, you can contact @𝒆𝒈𝒂𝒕𝒊𝒐𝒏.com to get information, or you can contact through the phone calls that you see on your screen to have more information about it. And I encourage each and everyone to participate because you gain more and really more from it. Now I will leave Mr. Kevin to continue with the demo phase for us to better understand what he explained to us theoretically. Mr. Kevin, you have the floor.
Okay, thank you. I'm going to switch here and switch over to show you. Well, so this is the AWS console, and yeah, you have various services, like I was saying. So you have compute services, storage services, database. So you have a lot of services that are provided by AWS that you can use directly. Some of the services you can use using your free tier, that is a free 12-month account, the 12-month period. But there are some services that are not free, and you have to pay before you use them. But all the services that I'm going to use today for the demo are all services that are available for the free period, for the 12-month period. So like I was showing in my diagram, you have API gateway, and you have the user that sends. Sorry, let me go back. So you have the user that sends a request to API gateway. API gateway is where you define a sort of an API that you link to your Lambda function that is doing all the processing for us. So this is here in API gateway. I define my API, and yeah, and it's going to give me a URL that I can use in my application, in my Java application or PHP application, whatever. I can use this API and just send a request to this API, and then get to send it to AWS. And this is my Lambda function. So in a Lambda function, you can write a Lambda function using various languages. You can use Python. You can use Node.js. So I decided to use Python for my Lambda function. So this Lambda function here is linked to my API gateway. So when you send a request through API gateway receives the parameter that you're sending and forwards those parameters to a Lambda function. So in my Lambda function, I receive the parameters here. So here I'm receiving the image that the user has uploaded through API gateway, I will save the image to my S3 bucket. S3 bucket is an object storage in AWS where you can store almost anything you want. You can store your pictures, you can store your videos, you can store your music files, and in Amazon S3. So I get the image that has been uploaded by the user here. I upload the image to my S3 bucket. Here, my S3 bucket here is called, I called my S3 bucket this. I created a bucket here. Let me show you. So here I'm in X3. So I have a bucket called 𝒔𝒆𝒒𝒂𝒕𝒊𝒐𝒏. So when I upload the image through to API gateway forwards the image to my Lambda. My Lambda extracts the image from my request and stores the image in my bucket. That's the first step. I store the image in my bucket. And next, after storing the image in my bucket, I call detect faces. Yeah, detect faces here is a function, it's a Python function I wrote. This detect face is going to call an AWS service called recognition, where it's going to take in as parameter the image that has been uploaded, and it's going to extract the age, it's going to detect, first of all, detect the face, if there are any faces in the image. And if there are faces in the image, it's going to try to determine what is the age of the person. It's going to try to determine whether the person is smiling or not. It's going to try to determine the gender, and it's going to try to determine the emotion of the person. So that's basically what it's going to do. So the person sends a request to API gateway. API gateway forwards the request to Lambda. Lambda extracts the image from the request and then calls the recognition service, passing in the image. And then recognition service is going to detect the age of the person, the gender, the emotion of the person, and that's the thing. That's it. The age, the gender, and the emotion. So that is basically it. So let's test and see. Sorry. So for this test, I'm going to use Postman to send a request to my API gateway with the image. So if you see where this URL here is my API gateway. It's the same as this URL here. So I'm going to send a post request with an image to that URL. So
Hello, Kevin.
yes.
You don't see anything.
You don't see anything?
No.
Oh, sorry. Wait.
It's completely black.
Sorry, 1 minute. Let me share my. Let me share the screen. Is it okay? Is it better?
Yes, it's okay.
Okay. So, like I was saying, this is my API here. Now I'm going to use Postman to test. So I'm going to upload. I'm going to upload an image. I'm choosing this image. So this image is going to I'm going to upload it, send the request to API gateway, and API gateway is going to forward the request. As we can see here, I'm going to upload the image to API gateway. API gateway is going to forward the request to my Lambda, and my Lambda is going to call the recognition service. So here I send the request. It's processing. Okay, so you see, so from the image, let me show you the image. Let me show you the image I uploaded. So this is the image I chose. So this is the image I chose. This image, and then this is the result I got. he said your age. So he says my age is between 24 and 38. So is the person in the image smiling? He said no, it's not smiling. What's the gender of the person? Is male, and the emotion is calm. So that is the work. That is what we saw here. So here we see. So here we see we get the image. We call recognition. We get the image, and we call the AWS service that is called recognition. And recognition has a method called detect faces, and it's going to get the image and try to detect the faces in that image, and it's try to extract some variables from there, like the age range, this whether the person is smiling, the gender, and the emotion. So that's what we got here. We got the age range, this whether it's smiling or not, and then the gender and the emotion. And we can see in S3 that if I refresh, you see that the image has been stored in my S3 bucket. So that's a basic serverless application. So you see that to have all that, I didn't have to start a server. I didn't have to do anything. Just have to everything is stored in Amazon, in AWS. Nothing is stored on my computer locally. So the lambda function here is stored in Amazon. And anytime I make a request, through my API gateway to this lambda function, what AWS does is that it's going to start a virtual machine, and with a server, and it's going to automatically execute this lambda function for me. So for the first time I'm calling this function, it's going to take some time because of the problem I told you earlier about cold start. Since it's the first time, it's going to take some time to start the virtual machine, deploy the function, and execute the request. But for all subsequent requests, it's not going to take the same time. Yeah. So that is it. So do you have questions? You can ask your questions now if there's any question. Is there any question? Do you need some clarifications on some things you don't understand?
Um, Excuse me, Mr. Kevin, please, can you kindly repeat the beginning of the demonstration that you did before? Because your screen was dark and never really understood what you were saying, mindful of the fact that you had a dark screen and you were explaining things that we didn't see. So please, can you just help us and you start the beginning of your demo and you help us to better understand? And another review that I heard from Mr. Adamu, he's asking in a more simpler words, please can you explain what is really serverless computing? Like not more in a computer way, but in a more simplified manner.
Okay. Okay. I'll start with the question. I'll start with the most question before moving on before restarting the demo. Okay. So simply, serverless computing is being able to execute code without worrying about infrastructure, without worrying about servers, without worrying about RAM or disk. Like I was showed in my demo. You see, I was able to create an application, a complete working application, without deploying any servers, without without writing any code. You see, I didn't write any code, but I didn't write any code locally. I mean to say, I didn't write any code locally. I don't have any servers on my machine. I don't have any. So I don't have, without using an IDE or without using any servers on your local machine, you are able to create a complete application. So serverless computing enables you to be able to create a complete application without worrying about the infrastructure side of things. So if you don't have if you don't have the logistics or the finances to put in place a server, or to rent a server from someone, you can use serverless computing, because cloud providers provide services which are relatively cheap and accessible to put in place uh, a complete application. A complete application that can be used by thousands of people without worrying about issues like accessibility, scalability, and and whether your application is going to crash or not. Because that is the one important aspect of serverless computing. That is, you don't worry about providing extra space or giving extra memory to your application. That is, when the number of users for your application increase, automatically the cloud provider is going to increase your memory, is going to increase your disk, and your users will not feel as if the application is getting slow. So you're going to get the same constant speed in the response of your application. So serverless computing gives you the capability as a developer to create an application without worrying or without thinking about infrastructure or network, but focusing solely on your business logic. That is, if you're building an application that does let's say, what can we say, that does stock management. So you just focus on adding stock, moving stock, adding products, creating products, deleting products. You don't have to focus about is my which server am I going to host my application on, or you don't have to bother about what RAM am I going to need, or how am I going to make my server connect, what's the networking between my servers going to be like, IP address, all those things. You don't have to worry about all those things. Just focus on writing your application code, whether it's in Java or PHP or JavaScript. You focus on writing application, and the cloud provider is going to take responsibility of providing you the infrastructure necessary for the execution of your application. I don't know if I've answered Adamu's question. So I'll move on now to show the demo again, since my screen wasn't showing. So like I was saying, this is the architecture. This is a simple architecture of the sample application that I executed. So for this application, you have a user that sends a request through a service, an AWS service called API Gateway. This service gets the request and forwards the request to another service called AWS Lambda, and this service AWS Lambda is where you write the business logic or the logic of your application. So this application is an application that gets an image from the user and try to detect the faces in that image. So he's going to get the image from the user, forwards the image to Lambda. Lambda is going to call an AWS service called recognition and pass in that image. And this service is going to detect all the faces that are found in the image and extract information from those faces, such as the age of the person, such as the gender of the person. So this is what I'm doing. This is what I'm doing here. So this function here, the Lambda handler, is a function that is being called by the API gateway. So this function now extracts the image from the request, and then passing the image to another function that is called detect faces. So the function detect faces calls an AWS service that is called recognition, and this service has a function that is called detect faces. So this function takes as parameter the image that the user sent and extracts some information from the face that has been detected by the service. So part of the information can be the gender, it can be the age of the person, it can be the emotion of the person. So to demonstrate that, I'm using Postman, and my API gateway. This is the link. This is a link of my API gateway. I'm using this link, so I'm going to make a post request to this link with my image, and this link represents my API gateway. So my API gateway is going to receive the image and forward the image to my Lambda function. So here, I'm going to select an image. Let me select an image here. I'm going to select an image. Let me choose this image. So I've selected the image. I'm going to send this request to my API gateway, which is then going to forward the request to my Lambda function. So I will send the request to my API gateway. So the request has been sent to the API gateway, and the API gateway forward the request to my Lambda function, and my Lambda function process the request and send me back the results. So these are the results I got back. So from the result, we see that the gender of the face that has been detected is female. The emotion is happy, and you see that the person was smiling, and the age of the person is between 22 and 34. So this is just a basic application, but this just shows you that you can how we can leverage the AWS services to build complex or powerful application without having to worry about infrastructure, to worry about machine resources or RAM resources, or networking problems. So is there another question, or do you want me to repeat the demo, or do you have another question concerning what I just showed you?
There's another question from
Okay.
Mrs. Amandine. She says, what is excuse me, let me interpret very well the question. So what is the advantages of doing serverless with AWS?
Okay. The advantage of doing serverless with AWS is that AWS has a lot of services that they are putting at the disposal of developers. That is, in your application, you won't have to rewrite. You won't have to rewrite many services, because such as authentication. AWS has a service that does authentication for you. AWS has a cloud database called DynamoDB, a NoSQL database. They also have a SQL database called MySQL SQL database, PostgreSQL database, all implemented in the cloud. So you won't have to manage the database yourself. You won't have to. AWS does the management of the database for you. So all what you do is just to configure. You come to AWS console, as you see here, as you are seeing on my screen, and you see all these services here. So you have databases that are ready for you. You have storage services that are ready for you, ready to be used. So you don't have to manage them on your own. You just come to the console here and you configure them. And once you configure them, your application can directly use them. So as you see, you saw the way I used a service to do face detection, image detection, and image analysis. So I don't have to write machine learning algorithms by myself. So it can happen that you want to develop an application that requires certain machine learning knowledge, but you have no knowledge in machine learning. So instead of wasting time to go and learn machine learning, learn how to build your own image, your own face detection algorithm. Instead of doing that, you just come to AWS, and you can directly use the services that AWS has provided to do face detection. So that's an advantage. So it enables you to develop application faster. So if you have an application that has to do face detection, instead of developing your own face detection logic, you can use directly the one that has been developed by AWS, and in that way you can develop your application faster. I hope that answers the question.
Yeah, thank you. It's very clear. Thank you.
Yeah. Any other question?
Bon, je vais poser ma part en français. Comme on a dit, c'est bilingue. Donc,
Vas-y.
est-ce que en développant avec les serverless, il y a des fonctions particulières à utiliser, ou bien c'est toujours la même syntaxe du langage, en fait, le langage qu'on utilise?
Non. L'avantage, c'est quoi? C'est que, comme je parlais des fonctions lambda, les fonctions lambda peuvent s'écrire en Java, les fonctions lambda peuvent s'écrire en Python, les fonctions lambda peuvent s'écrire en JavaScript. Donc, tu as la latitude d'utiliser le langage qui te convient pour écrire tes fonctions lambda. Okay. Et maintenant, tu définis tes codes, et tu as aussi la possibilité de créer des fonctions là en local, chez toi, sur ta machine locale. Tu n'es pas obligé de créer ça directement sur AWS. Même comme AWS te donne une interface où tu peux écrire directement le code, mais tu peux l'écrire en local et tu l'importes aussi ici. Donc, ça marche aussi comme ça.
Ok, merci. Autre question. Dans quel cas c'est plus indiqué d'utiliser, par exemple, les serverless ou pas? Parce que est-ce que si un projet avait beaucoup de features, ce serait intéressant d'utiliser, vu qu'on dépend entièrement de AWS, quoi.
Bon, on n'est pas obligé de dépendre d'AWS. Là, ce que AWS nous donne, c'est l'infrastructure, c'est l'infra en fait. AWS, il se charge de donner l'infra, de donner les machines virtuelles, les machines virtuelles avec la mémoire et tout. Il nous donne ça. Maintenant, tu peux avoir une application dynamique. Tu peux avoir ton application Java qui tourne, Java Spring, et tu as développé ça. Et il y a certains services, il y a certaines parties de l'application que tu veux utiliser que tu veux utiliser, que tu veux faire tourner sur AWS. Donc, tu n'es pas obligé de tourner toute ton application sur AWS. Tu vas voir ton application qui tourne sur ton propre serveur à toi, mais tu as d'autres parties qui tournent sur AWS. Par exemple, si tu as une application qui fait des calculs intensifs et tu n'as pas les ressources dans le serveur que tu as, n'a pas assez de ressources pour faire ces calculs-là, tu peux décider, OK, la partie de l'application qui fait ce calcul, tu l'implémentes sur AWS. Parce que AWS, eux, ils ont les ressources illimitées, on peut illimiter entre guillemets, mais ils ont assez de ressources.
Tout
De telle
à fait.
manière que dans la logique de ton application, tu exécutes ton application comme d'habitude, et au moment où tu as besoin de faire ces calculs-là, tu appelles juste un service, tu peux passer par, comme j'ai montré, par API Gateway qui te donne c'est comme un service REST, qui te donne un service REST que tu peux appeler, et tu envoies des paramètres, et AWS fait le calcul et te retourne des réponses que tu peux maintenant utiliser pour continuer la logique de ton application. Donc, ton application n'est pas obligée de tourner entièrement sur AWS.
Ok, merci. Mais si je parle, bon, dans le cas des serverless, c'est mandatory, je pense, donc c'est obligatoire. Puisqu'il y a des
Bon,
fonctions lambda qui dépendent, les fonctions qui dépendent
oui,
de la logique d'AWS. Donc.
oui, mais c'est ça, c'est là où API Gateway est très intéressant. API Gateway, je ne sais pas si tu réponds à ta question, Audrey.
Oui, 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 c'est bon, merci, c'est bon, merci. Ok.
Allô?
Oui, allô?
Allô,
Oui.
allô.
Peut-être c'est une répétition, mais c'est quoi la différence entre ça et peut-être une machine virtuelle que tu aurais prise sur un autre provider ou même sur AWS, toujours avec les EC2, par exemple?
Bon,
C'est quoi l'avantage, par exemple?
l'avantage, c'est quoi? L'avantage, c'est quoi? C'est que quand tu prends une machine EC2, par exemple, bien, tu prends une machine virtuelle sur un autre provider, c'est que toi, tu t'en charges comme j'ai parlé tout à l'heure de la scalabilité. Toi, tu te charges de la scalabilité, tu te charges de t'assurer que peut-être que si tu sais de début, tu as 200 utilisateurs et ton serveur gère encore le load. Maintenant supposons que en une nuit, si tu fais par exemple du e-commerce, en une nuit, tu as peut-être 500 000 utilisateurs qui essaient d'acheter des produits. Tu vois que si tu apprends un SC2, tu vas maintenant dire, OK, tu vas aller sur le serveur manuellement, dire, OK, j'augmente la RAM, j'augmente ça pour que mon serveur ne soit pas lent. Mais par contre, avec du serverless, par exemple, passant par du lambda et tout, ça fait que quand il y a ce montage à charge-là, automatiquement, AWS automatiquement fait la scalabilité de tes fonctions lambda. Ce qui fait que on ne sent pas qu'il y a un montage à charge. Et donc, les utilisateurs ne vont pas sentir qu'il y a un montage à charge. Donc, le service serait toujours fluide, comme si c'était un seul utilisateur qui était en train de se connecter.
Donc, OK. Donc, du coup, derrière ta facture, il y a toujours une question de coût qui est derrière. Parce que je sais que chaque service, plus tous ces services-là montent, plus ta facture est en train de devenir salée.
Oui, bon. Le truc, c'est que avec peut-être un truc comme Lambda, c'est tellement moins cher. Tu es facturé,
À l'utilisation.
le nombre de requêtes appelées. Nombre de requêtes appelées la seconde. Et je pense que c'est 0,01 $ pour chaque 1 million de requêtes. Donc, tu
OK.
vois que c'est
Bon. J'ai une
relativement.
dernière question. C'est juste que maintenant, côté applicatif, est-ce qu'il y a bon, je suppose que non, mais c'est toujours bien de demander. Il n'y a pas de
Ouais.
contraintes, par exemple, à un langage ou un langage de programmation précis ou genre, ça veut dire je peux faire peu importe le langage, quoi. Ça veut dire AWS Lambda ne gère vraiment que tout ce qui est infrastructure et on n'a pas de limite au niveau applicatif.
Donc, bon, ça dépend.
Parce
Ça dépend.
que, enfin, avant de répondre, parce
Ok.
que bah, je pense à des trucs comme par exemple la gestion d'erreurs, le monitoring et tout. Bon, on sait que par exemple la gestion, si on prend seulement le cas de la gestion d'erreurs, c'est des trucs que parfois, enfin, comment ils gèrent ça? Est-ce que ce n'est pas spécifique à là? Comment ça s'intègre tout ça sur AWS Lambda et tout, par rapport à ton
Ok.
langage, par rapport à tout?
Ok. Donc, ce qui se passe, c'est quoi? C'est que ça dépend maintenant comment tu as décidé de développer. Ça veut dire que si tu as décidé que as décidé que bon, si toute ton application donc que toute ton application sont les fonctions lambda que tu as implémentées. Maintenant, AWS a d'autres services qu'ils appellent CloudWatch. AWS CloudWatch. AWS CloudWatch, lui, il gère toutes les erreurs qui peuvent survenir dans les exécutions de tes fonctions lambda. C'est-à-dire que quand tu exécutes tes fonctions lambda, il y a peut-être eu des erreurs lors des exécutions. Peut-être tu as essayé de stocker, de sauvegarder les éléments dans la base de données, il y a eu une erreur et tout. Maintenant, CloudWatch, lui, il monitor l'exécution de tes fonctions. Et maintenant, tu peux le configurer à envoyer des mails. Tu peux dire, OK, quand il y a une erreur, tu embarques l'erreur, tu m'envoies ça par mail à telle adresse. Ce qui fait qu'il monitor continuellement l'exécution de tes fonctions et il t'envoie les erreurs. Donc AWS a pensé à des services que tu peux configurer sur tes fonctions lambda pour monitorer les erreurs. Et maintenant, pour les langages, pour les langages, maintenant, lambda même, comme je montrais cela, par exemple, là j'ai utilisé du Python. Maintenant, pour les fonctions lambda, tu as plusieurs langages, mais tu n'as pas tous les langages possibles. Donc, tu es limité sur le langage. Tu peux utiliser des langages comme du Java, du Python, du JavaScript. Mais ce n'est pas tous les langages que tu peux utiliser. Mais maintenant, si pour l'intégration avec ton application, ça veut dire que si tu peux créer une application chez toi à n'importe quel langage et passer par du API Gateway pour interagir avec ta fonction lambda. Ça veut dire que là, maintenant, l'intégration avec tous les autres langages peut se faire. Mais l'écriture de ta fonction lambda, tu es limité sur un certain nombre de langages à utiliser. Je ne sais pas si je réponds à ta question.
Oui, parfaitement. OK, merci.
Cool. Okay. Est-ce qu'il y a d'autres questions, d'autres points que vous voulez, des éclaircissements? Je ne sais pas. Bon. Donc maintenant, comme là j'ai utilisé Postman, juste pour clarifier, j'ai utilisé Postman, mais maintenant, si tu as une application, tu peux avoir une application mobile ou bien une application web qui a besoin de faire la même chose, de prendre des images, de faire des détections ou bien de image analysis sur des images. Là maintenant, ton application web ou ton application mobile pourra juste appeler ce endpoint ici. Tu pourras juste appeler ce endpoint ici et envoyer l'image et il recevra ce JSON-ci qui pourra interpréter maintenant et faire d'autres choses après. OK. S'il n'y a pas d'autres questions, merci pour votre attention et je pense que nous sommes arrivés à la fin de la présentation.
Merci à toi.
Merci. Over to you.
Thanks, Mrs. Eva, for this genuine presentation. Your explanation was really clear, and I hope each and everyone enjoyed it and you could understand the different points that were being stated in the question. As a reminder, please, about the training, don't forget about the training under DevOps and Big Data. You can make yourself to be trained. You can become a developer through our different training that we are giving you. You are having the chance and in fact make yourself to be trained and become somebody in the future. Don't wait for somebody to help you, but help yourself first and later on things in nature will help you. So I want to thank everybody for listening to this workshop and really I'm grateful to all those that send their comments and their questions, and I hope all of them were being answered and were being clarified on all their points that they never understood clearly. So, and I want to thank again Mr. Kevin for his genuine presentation. So now we'll meet next time for the next workshop, and I hope more shall come, and I hope those that were here today will be there again for the next presentation. Thanks everybody, and we'll see you next time.
Thanks. Thank you. Bye.